Hello, mm, I am Naveen Kumar Tiwari and I am just explaining that what problem I picked for the Demco assignment and why this problem is matter to developers and how did we scope it. I mean the problem we scope it. So the problem I picked is no log analysis for backend and applications. When an application fails, then developers usually check logs to understand what went wrong. But logs can be very large, noisy, and difficult to read quickly. A single log file may contain hundreds or thousands of lines, but only a few lines actually explain the issue. This matters to me because debugging production issue is a common and important part of backend development. When something breaks, then time matters. So developers need to quickly find the root cause, identify suspicious log lines, and decide what to check next. Reading logs manually can slow the process down, especially for beginners actually, or when the logs are messy. So I created a LogExplainer, a small API based project that helps analyze logs automatically. The user sends raw log text to the API and the application filters out the most relevant lines such as errors, warnings, exceptions, timeout, field status codes, and stack traces. Then it sends that filter log content to the local Llama AI model and it returns a structured explanation of these logs. I scoped the project carefully so it would stay practical and focused. Instead of building a full monitoring platform, dashboard, or alerting system, I focused on one core workflow, paste logs in, analyze them, and return useful debugging guidance. The output actually is intentionally very simple. It gives three things: the likely root cause, suspicious log lines, and recommended next steps. This keeps the project small enough to build and test, but still useful for real debugging scenarios. So I also choose to use a local AI model through a Llama instead of cloud service. So logs can be analyzed locally. That is useful because logs may contain sensitive application or infrastructure information. So that's why I choose right now to make it locally. So the main problem is developers need a faster, simpler way to understand important log errors without manually reading through noisy logs by line. So that is a thing that's why I choose that issue. I mean that problem. About the live demo of this project. So we do have a Llama model running in the background. We do have a Phi3 model of the Llama. So this is running in the background. And for make it quick, we do have a LogExplainer.htp file. So we set up everything here. A local HTTP client. So after running that, I mean building and running that application, I am going to open the terminal. So I just go in the CD and in the log explainer. Okay, I got it successfully. Then I run the .NET build as I am using the VS Code. Let's wait to build it. So yeah, it's building. So yeah, it's successfully built. Then let me run it. .NET run. Okay, let's wait for a while. Yeah, so it's successfully listening on the port HTTP localhost 5279. So I already set up a LogExplainer.html and I am just sending the request. I already set up here the JSON payload and I am just hitting the send request button. I mean send request link. So yeah, it's running. We are waiting for the response. Meanwhile, let me explain the let me explain the architecture and let me show the edge cases and other thing of this project. So first, as I explained, I have a Llama running model and my ASP.NET Core Web API is running on localhost 5279. So the main endpoint is in log controller. So this is the main endpoint. So this is the main endpoint, the analyze service, this one. So this endpoint log text in the JSON format. I will send a sample log where the application starts successfully, but then the database connection, let's say the database connection fails. So the request body is like logs and what I showed here. This is the request body. So when I send the request, the API receives the logs and passes them through the log filtering service. So here is the log filtering service. So it passes the log through the log filtering service. And after passing the log filtering service, after filtering the logs, it sends these logs to the Llama model. So here is the likely root cause should be related to the database connection being, I mean, if database connection being refused or something like this. But yeah, so request now completed. So this is showing 200 OK, and this is the response what we got. So this is the error. This is a suspicious line what do have in our logs. Error database connection refused, and these are the next steps what we need to fix here. Fix here the application from where we got these logs. So see, the edge cases is if somehow the Llama model is not running, there is a issue somehow in the Llama model in the service background, then it will give us the error actually. So let's say I will send a empty log request. So let me send a empty log request. I will just change here. So this is our log. So I just remove this and I just send a empty log request. Let's see what will happen. So it's giving us 400 bad requests. Logs can't be empty. So this is important because empty input is not useful for analysis and it prevents unnecessary cost to the AI model. Another failure scenario is when Llama is not responding, as I talked about it earlier. So in that case, the API returns a 503 service annual response. The response explains that Llama did not respond before the request timeout. This helps the user understand that API is not working, but the local AI service is unavailable or slow. So in this demo, we can see three important behavior. The happy path works, invalid input is handled safely, and AI services failure is reported clearly. The next step is how we built it. Walk through the code and architecture, explain the key choices I made and why. I will explain how I built that project and how the code is organized. So let me explain it. So this project is ASP.NET Core Web API called LogExplainer. This one, LogExplainer. The goal is to accept raw application logs, filter the useful parts. So we do have a log filter. So using that log filter, we will filter the useful parts. Here is we do have some keywords. So test this. So we also do have a unit test project here. I implemented the unit test project. So this contains unit test for the input and internal logic like log filtering, this one, and model response parsing. So here we do have also the model response parsing. The application start. So how this application start? So this is our LogExplainer and this is program.cs file. So the application is start in program.cs. So here I registered controller, controllers, Swagger, and Llama configuration, HTTP client and log filter service. So this is log filter service what I injected here. So I used here the dependency injection because it keeps the code cleaner and easier to test. For example, log analysis service receives HTTP client, Llama option, log filter through its constructor. So let's say this is our log analysis server. So we injected here in controller through constructor. So the main API endpoint is in log controller.cs file. So the root is this, the root API logs. So this is our root, and analyze, this is the analyze. So this is our whole root API logs analyze. So this controller accept a log request. So this is the log request. So this controller accept the log request object which contains one property called logs, and yeah, we are also passing the cancellation token. Before doing anything else, the controller checks if the request is null or if logs are empty. These things is checked by the controller. So log analysis service is the main service that coordinates the analysis flow. First it calls log filter. The reason I created a separate log filter class is because log filtering is deterministic logic. It doesn't need the API or Llama. By separating it, I can test it easily with unit test. So that's why. So log filter splits the raw logs into the lines and looks for suspicious signals such as error, warn, fatal, exception, timeout, refused. These are the thing: exception, timeout, refused database, auth memory issue, correlation IDs, HTTP 500, label status, and stack traces. All these things we are filtering here. When it finds a suspicious line, it also includes nearby context lines. This is important because one log line alone may not explain the full issue. The line before or after it may contain the request ID, service name, or retry message. The filter also handles edge cases. If it does not find anything suspicious, it still sends the first 100 lines instead of sending nothing. And if the logs are very large, it truncates them so the AI model does not receive too much input. After filtering, log analysis service builds a prompt for Llama. One important choice I made was to ask the model to return only JSON in a fixed format. The response must contain the fixed format JSON. I also added a safety instruction that says the log contents are untouched data. The logs are placed inside the clear delimiters. This helps prevent a log line from acting like an instruction to the AI model. Then the service sends a request to the Llama using HTTP client. The Llama base URL, model name, timeout, and max output tokens are stored in appsetting.json. So here is the appsetting.json. So we do have these things here in the appsetting.json. So after Llama respond, the app uses model response parser. Model response parser, this one. The parser validates the model response and convert it to the log analysis result object. I added this parser because AI output can sometimes be imperfect. For example, some models wrap JSON inside markdown code fences. So the parser handles both plain JSON, markdown wrapped JSON. So Llama is unavailable for timeout, but the API response 503 service unavailable. So Llama responds, but the response is not valid JSON. The API returns 502 bad gateway. I separated these cases because the main different things. If 503 means the AI service is unavailable. If 502 means the downstream service responded, but the response was not usable. So finally, I added LogExplainer.test. So as I described earlier, I do have the LogExplainer.test. So the test cover important edge cases like detecting error lines, detecting HTTP 503, detecting stack traces, repeated errors, large log truncation, and parsing model responses. This gives us confidence that the core logic still works by using the LogExplainer.test. Controller receives the request, log analysis service coordinate the process, log filter extract useful log lines, Llama analyze the filter logs, model response, parser validate the AI response, the controller return a clean JSON result. So I kept the design small and focused because the main goal was not to build a full monitoring system but to solve one clear workflow, take logs, explain the likely issue, and suggest next step. So the next thing, what does not work, what would you improve with more time? So first of all, the quality of the explanation depends on the local AI model. I am using Phi3 through Llama, which works for simple examples, but it may not always give perfect root cause analysis for the complex production log. Second, the API depends on Llama being installed and running locally. So if Llama is stopped slow or the model is not installed, the API cannot complete the analysis. I added error handling for this, but it is still an external dependency. Third, this project does not have a front-end UI yet. Right now, the user has to call the API manually through PowerShell, Swagger, or another HTTP client. With more time, I would build a simple web interface where users can paste logs and view the explanation clearly. Fourth, the log filtering is rule based, so it looks for keywords 500 label states code, static traces, and repeated errors. This is useful, but it can still miss important lines if the logs use unusual wording or custom format. Fifth, there is no authentication or authorization for a real production system. This would be important because logs may contain sensitive information like tokens, user ID, database details, or internal service names. So I would also improve privacy and security by masking sensitive values before sending logs to the model. So for example, I am sending password, API key, tokens, emails, and connection string. With more time, I would add integration test for the full API flow, better logging inside the application, a health check endpoint for Llama, and support for uploading log files. The project works as focused prototype, but it is not a complete production monitoring tool yet. It serves the core workflow of explaining logs, but it still needs better security, usability, integration, testing, and model reliability before. So this is the problem I picked and developed. So that's it. Thank you.